Have you ever wondered how a camshaft can change the way an engine delivers torque? Or why one type of camshaft can allow an engine to rev higher than another? In this video, I'll explain some theory and terminologies used when discussing camshaft operation. Some common terms and acronyms used in relation to the piston and crankshaft are top dead centre, after top dead centre, before bottom dead centre, bottom dead centre, after bottom dead centre, and before top dead centre. Some common terms in relation to the camshaft are duration, the period of valve opening or closing measured in crankshaft degrees. Overlap, the period both valves are open at the same time, measured in degrees of crank rotation. Valve lift, the amount of valve movement from closed to full open, measured in millimetres or thousandths of an inch. During the power stroke, both valves are closed. The rocker arms or cam followers are navigating the base circle of the camshaft. We'll use this as a starting point. The expanding gases within the cylinder push the piston down, rotating the crankshaft. Just before bottom dead centre, the exhaust valve opens. By this stage, the effective work done by the expanding gases has diminished. There is no more usable power to be obtained by keeping the exhaust valve closed any longer. By opening the exhaust valve at this point, the pressure in the cylinder can be utilised to start the waste gases flowing past the valve and through the exhaust port. The ideal angle of exhaust valve opening changes with engine speed and load. This is a direct relationship to cylinder pressure. At low crankshaft speed, there are benefits to opening the exhaust valves closer to bottom dead centre. This is where cylinder pressure is at its lowest and gases can be released easily. At high crankshaft speed, the ideal exhaust valve opening would be earlier, as more time is needed for the gases to escape. As the piston approaches top dead centre, the intake valve opens. Slightly after top dead centre, the exhaust valve closes. The angle between the intake valve opening and exhaust valve closing is called valve overlap. Valve overlap has a significant effect on the quantity of exhaust gases remaining in the cylinder. Near the end of the exhaust stroke and the beginning of the intake stroke on this engine, the valves are rocking. This is valve overlap. At high crankshaft speed, it is desirable for the maximum possible quantity of exhaust gas to be expelled from the cylinder. This allows the largest amount of fresh air-fuel charge to enter on the intake stroke. High-speed torque can benefit from an increased valve overlap angle due to the exiting exhaust gases aiding the intake of fresh fuel air charge. This action is known as scavenging. This can be further enhanced by tuned length exhaust systems on multi-cylinder engines. However, this large valve overlap angle can result in much higher emissions at lower engine speeds, as this air-fuel charge can flow directly into the exhaust. At low crankshaft speeds, a small overlap is desirable, achieving improved emissions and a smoother idle. In a production engine, a compromise is sought between a smooth idle, high-speed torque and low emissions. One solution to this problem has now been addressed with the introduction of VVT or variable valve timing. Another way to overcome this compromise is to use a turbocharger. You'll notice that the closing angle is after bottom dead centre, even though the piston is now on the compression stroke. The piston movement around bottom dead centre has little effect on airflow into the cylinder, so it is beneficial to keep the intake valve open until increasing cylinder pressure affects the incoming airflow. This is because of the relationship between crankshaft angle and piston speed. There is typically around 30 degrees of crankshaft revolution at top dead centre and bottom dead centre, where piston motion and travel is relatively low. Let's have a look at this on an engine. I'll mark the indicator every 10 degrees of crankshaft revolution between top dead centre and bottom dead centre. As can be seen, in the first 30 degrees of crankshaft revolution, there is very little piston movement. As the piston approaches 90 degrees after top dead centre, we can see the piston has reached its peak acceleration. From 90 degrees after top dead centre to bottom dead centre, we can see the piston is now reducing velocity in preparation for its return to top dead centre. The volumetric efficiency of any engine is dependent on the intake valve closing angle at any given speed. This is due to only having atmospheric pressure to fill the combustion chamber. For maximum torque, the intake valve should be closed at the point where the greatest mass of fuel-air charge can be trapped within the cylinder. For a production vehicle, this angle of closure is a compromise between high and low speed torque requirements. From this point, the piston travels back to top dead centre on the compression stroke, ready for ignition. The cycle starts again. Valve lift directly affects the quantity of air flowing into and exhaust flowing out of the cylinder. This is a major factor contributing to engine performance. There are limitations to how much lift can be accommodated without compromising piston design. Generally, pistons are profiled with valve reliefs to accommodate extended valve lift. An engine's maximum power output will benefit from as much lift as possible, up to the point where other features such as manifold design and port sizing begin to restrict airflow. A high lift cam profile has an adverse effect at low crankshaft speeds due to the intake air velocity being slower. This will reduce cylinder turbulence. This decreased turbulence will cause improper mixing of the fuel-air charge, poor engine performance and higher exhaust emissions. A smaller valve lift will increase intake air velocity and promote greater turbulence, ensuring an even air-fuel charge throughout the cylinder at low crankshaft speeds. As crankshaft speed increases, a small valve lift value will begin to restrict the airflow into the cylinder, resulting in a torque reduction at higher crankshaft speeds. Intake swirl valve systems may counteract poor turbulence caused by high lift cams. Valve duration refers to the number of crankshaft degrees the valve is raised off its seat on either the opening or closing ramp of the cam lobe. Increasing the duration will keep the valves open longer, allowing more airflow into the cylinder. This can improve high-speed torque. If the duration of the cam lobe is increased without altering the lobe separation angle, the valve overlap angle will increase. Lobe separation refers to the angle, measured in camshaft degrees, between the centre lines of the intake and exhaust cam lobes. Altering the lobe separation angle will change the nature of torque delivery, idle quality, emission output, and valve overlap. Advancing or retarding the camshaft to crankshaft timing moves the torque curve up or down the RPM range. It achieves this by changing the start time of valve events within the cylinder. By advancing the intake camshaft, the intake event will start earlier in relation to piston location. This will improve low-speed torque. By retarding the camshaft, the valve events happen later in relation to the piston location. This will improve high-speed torque. Incorrect cam belt or chain installation can also result in contact damage between the piston and valves. Some manufacturers build in a safety net on their engines to protect them from damage if a cam belt or chain failure occurs. These are known as free-spinning engines. On these engines, with the intake and exhaust valves open and the piston at top dead centre, there is enough clearance so contact will not occur. Most manufacturers design camshaft valve timing with a compromise between low and high speed torque curves. The use of VVT is one way manufacturers can overcome this limitation. And that's valve timing explained. If you're still unsure or have missed anything, please watch it again. Understanding the system before commencing work ensures an efficient, correct and cost-effective repair. Thanks for watching. See you next time.